Hi everybody, this is the Math 31 optimization review. This is question 10. This is actually a problem that's you might recognize from Math 20. Comes up again just because now we've got kind of better tools for solving this. So a farmer has 2,400 meters of fencing with which to enclose a rectangular field, and then to divide it into 3 equal parts by building 2 more fences running parallel to one of the sides. Okay, now I don't know, I remember in Math 20 that was hard for people to get their heads wrapped around. It's probably no different now, but what this is describing is this. Here's our field. Let's maybe call this X and Y, and then we're going to put 2 more fences, okay, along here. Now, it doesn't really matter where those go, okay, at all. They could be right up against each other, whatever. There's no reason to assume that they are oh, I'm sorry, it does say equal parts. Sorry, you don't actually need it to say the 3 equal parts for this question to work here. That is really just to allow people, if you wanted to, instead of making Y the whole side, you could make Y these little pieces here. But there's really no need for it. What dimensions would enclose the largest area? Okay, so area here is going to end up being X times Y. And now let's just talk about this, or think about this real quick here. What is the relationship between X and Y here? Well, we've got 1, 2, 3, 4 X's, and at this point, the way I'm writing it, 2 Y's, and this has got to be an expression for the entire perimeter, all of the perimeter for everything here, which will be that 2,400 meters of fencing that the farmer has. Now we're pretty lazy here, so let's maybe divide everything through here by 2 to get 2x plus y is equal to 1,200. So y is equal to negative 2x plus 1,200. So here's an expression for y in terms of x, and that's helpful because now I can take and make this x times negative 2x plus 1,200, negative 2x squared plus 1,200x. Now the reason why that's significant is because now area is in terms of just a single variable, which means when I take the derivative, it's just a lot easier to work with. So the derivative of area will be negative 4x plus 1,200. Oh, now, and by the way, I hope you can recognize that this shape here for area, this is a parabola that opens down. So we are going to be finding the maximum. Okay, I mean, I shouldn't have to go through and investigate intervals of increase and decrease. I already know what that is. So I can move on very confidently, set that equal to 0, make that 1,200 is equal to 4x, divide, and get that 300 is equal to x. Okay? And if x is equal to 300, I can come back over here to my expression to get y, and it'll turn out y is equal to 600. And so these are the dimensions right here. So you might want to think of that as 300 meters, okay, by 600 meters.